Problem 3. A number dividing 70 and 103 results in the following remainders: a and 2a plus 2. So we're being asked, what is the value of a? If you've ever watched my previous number theory videos, a lot of them always emphasize that whenever we're going with remainders or something and it says a number dividing, when it says dividing right here, it doesn't mean that it's the dividend, but the divisor. So it's the number that comes after 70 and 103, not being divided by, but dividing. So the two equations we can write out right now is 70 divided by a has a remainder. Let's say has a remainder of a, and we also know that 103 divided by a will have a remainder of a, so remainder of 2a plus 2. And I'm just going to group these together as a bracket to show that they are a group. So here, what we're trying to do is we're trying to find a right now, the uppercase a right now, because then if we know the uppercase a, we can easily find out the lowercase a. So here, what we're going to do is, you know what, I'm just going to erase this to b so I don't have to say uppercase and lowercase every single time. So you can give this variable any single letter. It can even just be a symbol, actually, that doesn't really matter. So a and b. So the first step is try to try to eliminate a from all of these equations. So how do we do that? Well, in order for it to be completely eliminated, you need to subtract something by itself. So let's first try to make these two remainders become the same. So how can we do that? Well, if we add 2a, if we multiply 2 to this first equation, so it becomes 2a, and we subtract both sides of this bottom equation by 2, we'll have 2a and 2a on both equations. So let's first multiply the first one by 100 by 2, and we get 140 divided by b is equal to, after being divided, it will have a remainder of 2a. And then what we can do for the second equation is subtract 2 on both sides. So 103 becomes 104. That divided by b, and we have a remainder of 2a. So now, as you can see, we have 2a on both of these equations. 2a and 2a. So since they both are the same type of remainder, then we can easily subtract. We can subtract 101 from 140, and that gives us 39. So 39 has the factors. 39 has the factors 1, 3, 13, and 39. So out of these four numbers, we just have to see one that a might be. So these are all possibilities of a. Okay, these are all possibilities of a. Now we can substitute each of these into a. Into b. These are all different possibilities of b. We can substitute these into b to see which of them work. So pause the video right now, and you can do that. All right, so this part is really simple. It's really just putting these numbers into these equations, see if they match these equations. And I'm really not going to go into that because I'm sure that you can handle that pretty easily. And this is something that we've been doing repetitively throughout the other number theory problems. So we're sort of in a routine now. I think you know where we are at. So in the end, you will eliminate 1, 39, and 3, and our final possibility for b would be 13 and only 13. So now, since b is 13, let's substitute that in. And 70 divided by 13 is equal to 5, right? 5 times 13 is 65, with a remainder of 5. And that remainder would be a. So our final answer is a is equal to 5.